Hello there. Welcome to the second video of machine learning problem solving series. So in the previous video, we solved gradient descent, and today we are going to understand two of the most important activation functions in deep learning, sigmoid and ReLU. We will understand what activation functions are, why neural networks need them, and how sigmoid and ReLU actually work visually. By the end of this presentation, you will clearly understand why these functions are used and why they are so important in neural networks. Uh, what are activation functions? So let's first understand the core problem. Imagine stacking multiple linear layers in a neural network. That means a simple set of machine learning algorithms stacked over one another. You might expect the network to become smarter and more complex, but, but mathematically, combining linear functions still produce another linear function. As you can see here, if you stack multiple linear functions, it is still linear. That means no matter how deep the network becomes, it still behaves like a simple straight line model. And this is exactly where activation functions become important. Activation functions introduce non-linearity into the network. This allows neural networks to learn. So curves, patterns, images, language, and complex real-world relationships all use activation functions. Now, what is sigmoid? Now let's talk about the sigmoid activation function. The sigmoid function takes any input value and squishes it between 0 and 1. As you can see, this makes it very useful when we want probability-like outputs. For example, value close to 1 represent high confidence, value close to 0 represent low confidence. This sigmoid curve is smooth and S-shaped. This would be clear in the later images. As the input becomes very large, the output approaches 1. As the input becomes very negative, the output approaches 0. Now let's talk about ReLU. So ReLU stands for rectified linear unit. ReLU is one of the simplest and most powerful activation functions. Its rule is very straightforward. If the input is negative, the output becomes 0. If the input is positive, the output stays the same. That means negative values are removed, positive values pass through directly. This simplicity makes ReLU extremely fast and efficient. Now, these are some of the examples, like how the probability assign gives us the output. Now, these are the graphs for the ReLU and sigmoid. So as you can see here, sigmoid is S-shaped and it gives 0 for the outputs which have low probability and 1 for the outputs which are higher probability. Whereas in rectified linear unit, you can see the negative outputs are squished to 0, whereas the positive inputs pass through directly. So let's begin with the implementation. Now let's begin with the implementation of sigmoid and ReLU function. So as you can see, we are given with the sigmoid function which takes z numpy array as input. So what we have to do is we have to transform every element in the z numpy array in the range of sigmoid. So we have to basically apply the sigmoid transformation on every element of z. So how we'll do it? So we will be using NumPy library for this, and then using it we can directly return NumPy.round because we have to round our answer to the 5 decimal places. Then we can implement like this. We have to apply a formula which is np dot 1 upon 1 plus n np dot exp, which is e to the power and then minus z, and after it we have to write 5 because we want to round it to 5 decimal places. And for the ReLU function it's simpler. We have to just return the maximum of the maximum. If the input is negative, we have to return 0, and if the input is positive, we have to return the number itself. So we'll return np dot round, not round because we don't have to round it to decimal places, so we'll just use maximum of 0, and yeah, we can run it. That works, and we'll just submit it. And yeah, this is how we implemented Sigmoid and ReLU function. So in this video we learned what activation functions are, why they are important, and how Sigmoid and ReLU work. Activation functions are one of the key reasons neural network can learn complex patterns. Without them, deep learning would not be possible. And in the next episode, we will solve another important machine learning concept step by step, which is softmax function. So thanks for watching, and I'll see you in the next video. Bye bye.